Europe shouldn't exist like this. That may sound impossible. But look at a map. Cities like London, Amsterdam, Berlin, and Oslo sit as far north as some of the coldest parts of Canada. So why aren't they buried under snow for most of the year? Why can millions of people live, farm, and build some of the world's richest economies in places that should be far colder? The answer isn't on land. It's hidden beneath the Atlantic Ocean. An invisible system, stretching thousands of miles, quietly moves heat across the planet. It has helped shape Europe's climate, supported global trade, fed millions of people, and influenced the rise of entire civilizations. But scientists are now watching this system more closely than ever before. Because if it continues to change, the consequences may reach far beyond Europe. They could affect food, energy, shipping, weather, and the lives of billions of people around the world. And here's the most surprising part. Most people have never even heard its name. Stay with me until the end, because what you're about to discover isn't just the story of an ocean current. It's the story of how one invisible force may have quietly shaped the modern world, and why scientists are asking whether it could shape its future, too. Imagine standing in the heart of London on a winter morning. The streets are busy. The River Thames flows freely. Life carries on as usual. Now imagine standing at the exact same latitude, but on the other side of the Atlantic. You wouldn't be in another European city. You'd be in one of the coldest inhabited regions of Canada. The difference is astonishing. Many of Europe's largest cities sit as far north as places where winters are far harsher, lakes freeze for months, and snow dominates the landscape. So why doesn't Europe look the same? At first, the answer seems simple. Most people believe it's because of the Gulf Stream. But that explanation tells only part of the story. The real answer is far more complex and far more fascinating. Hidden beneath the Atlantic Ocean is an enormous circulation system that quietly redistributes heat across the planet. It has operated for thousands of years, long before modern nations existed, long before the first skyscrapers, and even before many ancient civilizations were born. Without it, Europe's climate might have been dramatically different. Its growing seasons could have been shorter. Its ports could have faced much harsher winters. Its history, its economy, and perhaps even its rise as one of the world's most influential regions might have followed a very different path. This isn't just a story about weather. It's a story about geography, history, economics, and one of the most powerful natural systems on Earth. Because this invisible engine doesn't simply move water. It helps move heat, supports marine ecosystems, and quietly influences the lives of hundreds of millions of people. For generations, it has done its job almost unnoticed. But today, scientists across the world are paying closer attention than ever before, because there are growing signs that this ancient system may be changing. And if they're right, the question is no longer why Europe is unusually warm. The real question is, what happens if the system responsible for keeping it that way begins to slow down? For decades, most people believed Europe stays warm because of the Gulf Stream. It appears in documentaries, school books, and everyday conversations. But scientists now know that explanation is incomplete. The Gulf Stream is only one part of a much larger system. The real engine is something far bigger, something far more powerful. Scientists call it the Atlantic Meridional Overturning Circulation, or simply AMOC. Imagine a giant conveyor belt stretching across the entire Atlantic Ocean. On the surface, warm tropical water begins its journey from the Gulf of Mexico, moving northeast across the Atlantic toward Europe. As this water reaches the icy seas near Greenland, something remarkable happens. The freezing Arctic air cools the water, sea ice begins to form, and more salt is left behind. The water becomes colder, saltier, and much heavier. Eventually, it sinks thousands of meters beneath the surface. And that's where another incredible journey begins. Hidden in complete darkness, this freezing water slowly flows south across the floor of the Atlantic Ocean. A single drop of water may take hundreds or even thousands of years to complete the entire cycle. This isn't just an ocean current. It's one of Earth's greatest climate engines, operating quietly for thousands of years. It transports heat, circulates oxygen, carries nutrients that support marine life, and even helps store carbon deep inside the ocean. Without this circulation, the Atlantic and much of our planet would function very differently. Every second, this invisible engine moves more water than all the rivers on Earth combined. Yet almost nobody notices it. Because unlike hurricanes, earthquakes, or volcanic eruptions, this giant engine works quietly beneath the waves. For thousands of years, it did its job almost perfectly. Generation after generation, it kept moving. Silently, reliably, never making headlines. But today, scientists across the world are watching it more closely than ever before. Because for the first time, there are growing signs that this ancient engine may no longer be running the way it once did. And if that's true, the question is no longer how AMOC works. The real question is, what happens when one of Earth's most important systems begins to slow down? For thousands of years, this invisible engine worked quietly. Season after season, century after century, moving enormous amounts of water without anyone noticing. But today, scientists are seeing something unusual. Not because the ocean has stopped, but because it may no longer be moving the way it once did. The warning begins in Greenland. Every summer, billions of tons of ice melt into the North Atlantic. At first, it sounds harmless. After all, it's only fresh water. But AMOC depends on cold, salty, heavy water. That's the water that sinks and keeps the entire system moving. Fresh water changes that balance. It makes the ocean less salty, less dense, and less able to sink. Imagine slowly taking power away from a giant conveyor belt. It doesn't stop overnight. It gradually begins to slow. That's exactly what scientists are trying to understand. Across the Atlantic, research ships, satellites, underwater sensors, and deep-sea instruments monitor this system every day. They measure temperature, salinity, and the movement of the ocean itself. And many observations suggest that this circulation has weakened compared with the past. Exactly how much is still debated. Exactly how fast remains uncertain. That's how science works. Some climate models suggest AMOC may weaken gradually throughout this century. Others warn that continued warming and increasing freshwater could eventually push it toward a critical tipping point. No one knows exactly when that could happen, but nearly every climate scientist agrees. This system deserves close attention, because if one of Earth's greatest climate engines keeps losing strength, the consequences won't stay in the ocean. They'll reach our weather, our food, our energy, and eventually, our daily lives. So the real question is no longer whether this system matters. The real question is, what happens if it keeps slowing down? Imagine waking up one winter morning and realizing the climate you've always known is slowly disappearing. Not overnight, but slowly enough that most people never notice. That's how climate systems change. If AMOC continues losing strength, Europe could become one of the few places on Earth that struggles to warm even as the rest of the planet gets hotter. Scientists don't expect a Hollywood-style ice age, but they do expect a different Europe, longer winters, more cold waves, more unpredictable weather. Weather doesn't just change temperatures, it changes civilization. Colder winters mean higher demand for electricity, natural gas, heating, and infrastructure. Every extra demand comes with a cost. If energy prices are already high, that pressure spreads through the entire economy. Then comes agriculture. Farmers depend on predictable seasons. Changing rainfall and shorter growing seasons make harvests less reliable. When harvests become uncertain, food prices rise. Today's food supply doesn't stay in one country. One failed harvest can affect millions of people across global supply chains. The same is true for the ocean. Fish follow changing water temperatures. If the Atlantic changes, entire fishing communities may have to adapt. Then comes global trade. More storms, longer shipping routes, higher costs, slower deliveries. Small disruptions can quickly become global problems. Suddenly, an invisible current beneath the Atlantic Ocean is affecting something everyone understands: the cost of living. That's why scientists aren't just asking whether AMOC is changing. They're asking whether the world is ready. Because if one ocean system can influence weather, food, energy, trade, and entire economies, this was never just Europe's story. It's everyone's. It's easy to think this is Europe's problem. After all, Europe is the region most closely connected to the Atlantic Ocean. But oceans don't recognize borders, neither do their consequences. What happens in one part of the Atlantic can eventually be felt thousands of miles away. Our world is more connected today than at any other time in history. A drought in one country can increase food prices in another. A disruption at sea can delay factories on the other side of the planet. One climate system can influence global markets. Scientists believe that if the Atlantic circulation continues to weaken, the effects won't stop with Europe. Rainfall patterns could shift across Africa. Monsoon systems that billions of people depend on in Asia could become less predictable. Some regions may receive too much rain, while others may receive far less. For countries where agriculture depends almost entirely on seasonal rainfall, even small changes can have enormous consequences. Along the eastern coast of North America, rising sea levels could become an even greater challenge, not because the ocean is expanding faster, but because changing circulation can redistribute where water naturally accumulates. In the southern hemisphere, the effects could even reach Antarctica. Warmer waters may accelerate ice loss, adding even more uncertainty to future sea level rise. No single country can solve a problem like this alone, because the ocean connects every continent. That's why governments, research institutions, and scientists continue investing billions of dollars to understand what's happening beneath the Atlantic, not because they know exactly what will happen, but because they understand what's at stake. The truth is, this isn't just a climate story. It's a food story, an energy story, a trade story, a security story. Above all, it's a story about how deeply connected our modern world has become. An invisible current beneath one ocean has the power to influence billions of lives. Perhaps that's the most extraordinary part of all. The greatest forces shaping our future are often the ones we never see. So is Europe really heading toward another ice age? The honest answer is no one knows, not yet. Scientists don't agree on exactly when, or even if AMOC could ever reach a tipping point. Some studies suggest the system may simply weaken over the coming decades. Others warn that continued warming and the rapid melting of Greenland's ice could eventually push it past a point where recovery becomes extremely difficult. That's why the world's leading climate scientists aren't making predictions. They're collecting evidence. Every day, research ships cross the Atlantic. Thousands of instruments hidden beneath the ocean continue measuring temperature, salinity, and the movement of water. Satellites watch from space, while supercomputers simulate the future. Understanding this system may become one of humanity's greatest scientific challenges. But perhaps the most important lesson isn't about Europe, Greenland, or even the Atlantic Ocean. It's about connection. One invisible current can influence weather, food, energy, shipping, economies, and the lives of billions of people. It's a reminder that our world is far more connected than it appears. For thousands of years, this great ocean engine helped shape civilizations without asking for attention. Today, for the first time in history, human civilization may be influencing the engine itself. Whether AMOC eventually slows or continues flowing will be answered by science, not headlines, fear, or speculation. Until then, the Atlantic will continue reminding us that some of the greatest forces on Earth are completely invisible. Perhaps the future isn't decided by the things we can see. Perhaps it's shaped by the things we almost never notice. Because history has always been written by nature. The only question left is, what story will it write next?